Good morning and good afternoon, everyone. Thank you for tuning in today. My name is Cora Lingerski and I'm with the representative of German business. And I'm pleased to welcome you to the second part of our Transatlantic Energy Efficiency Forum. Today's topic is Decarbonizing Buildings, the role of electrification. This week, we are hosting a virtual building efficiency program for German companies in that space. In the course of this program, we have organized today's conference. I invite you to join me for the next 2 hours to learn about German and Washington developments, policies, and initiatives in the building efficiency sector. We will hear 2 keynote speakers from both sides of the Atlantic, 3 German companies, Lunos, LED Light, and Friedemann Facade Lab, and a great panel discussion that will discuss transforming buildings. How can electrification be combined with other solutions? But before we begin, I want to thank our great partners for supporting this event. All of them either foster the transatlantic exchange between Germany and the US and/or focus on creating a sustainable future. The German Federal Ministry of Economic Affairs and Climate Action, the Council General of the Federal Republic of Germany of San Francisco, the Council General of the Federal Republic of Germany of Los Angeles, Germany Trade and Invest, RENAC, Shift Zero, the Northwest Energy Coalition, Spark Northwest, Northwest Energy Efficiency Council, Clean Tech Alliance, the US Green Building Council LA, and Better Building Challenge LA. In addition, I would like to thank my team, Olivia Lambert, Felix Loxen, and Evi Segura, for the support in bringing this program together. Should you have any technical problems, please contact them in the chat directly. For questions to the speakers and the presenting companies, feel free to use the Q&A function, and the questions can be answered by the speakers directly. To start the conference, I would like to hand it over to our CEO, Sven Torsten Potthoff, for a few welcome words.
Cora, thank you so much for putting all of this together. Ladies, gentlemen, dear all, good morning in Germany and good afternoon probably. No, other way around. Good morning in Germany. No, good morning here and good afternoon in Germany. I'm so sorry. That was the wrong way. Very officially, on behalf of the German-American Chamber of Commerce in the Western US, it is my pleasure to welcome you all to today's webinar titled Decarbonizing Buildings, the Role of Electrification. Today, focusing on Washington State. In 2021, last year, residential and commercial buildings accounted for 40% of total energy consumption in the US. But however, the US states of California and Washington, with their exemplary climate targets, offer a good basis for decarbonizing the energy and building sector. California has long been considered the leading US state in terms of environmental and climate policy. Among other things, it aims to have 100% of its electricity come from renewable energy by 2045. Washington State has similar goals to use 100% carbon-free energy by 2045 and to reduce greenhouse gas emissions by 95% by 2050. And in addition, regulations such as Washington's Clean Building Standards or California's Building Energy Efficiency Standards are helping to better manage building energy use. The cities of Los Angeles or Seattle have very good framework conditions for energy efficient construction and also the implementation of energy-friendly technologies. The main drivers of market development are legal framework conditions, economic and social trends, but also technical trends. So again, we all seem to be on the right spot at the right time, which is my humble take on a topic you're all dealing with on a regular basis. As I'm surely not the expert, I will leave it at that. I wish us all an interesting and inspiring webinar full of insights on this important topic. Thank you all for being here. And now back, Cora, to you.
Thank you, Sven. Next, we will hear welcome remarks from Mark Lenderman, Counselor for Economic and Commercial Affairs at the Council General of the Federal Republic of Germany of San Francisco. Welcome, Mark.
Thank you so much. Thank you for the kind introduction, Cora and Sven. And thank you so much for having me. It's an honor to participate today and to say some welcoming remarks on behalf of the German Consulate General. There couldn't be a better timing for today's event. Yesterday, the first US-Germany Climate and Energy Summit kicked off in Pittsburgh. In light of the climate and energy partnership that was launched last year, it is great to continue the dialogue here with a focus on the West Coast. And it's very valuable for us to zoom in on the building sector. 34% of Germany's energy demand and 30% of our greenhouse gas emissions are generated by the building sector. In light of this relevance of the building sector, the German government has set itself the goal to achieve net greenhouse gas neutrality in the building sector by 2045. Against this background, low energy refurbishment of the existing building stock is crucial for the success of the energy transition. Our strategy for the building sector basically consists of 3 pillars. First, significant and sustainable reduction of energy demand. Energy efficiency in buildings is a key priority for the energy transition. Therefore, insulation plays an important role. Many policy instruments have been in place since a couple of years. For instance, tax incentives for energetic refurbishments and federal subsidies for efficient buildings. The second pillar is direct use of renewable energies wherever possible. So far, gas remains the main source for energy consumption in German buildings. In order to get more renewable energy into the building sector, we focus on heat pumps and heat networks. The third pillar is efficient use of renewable electricity through what we call sector coupling. The German federal government has already adopted a set of measures to ramp up the electrification of the building sector. One of the instruments is a so-called heat pump initiative. One element of this new initiative is capacity building to make sure that our workforce has the skills that are needed. Also, the German government is currently working on a reform of the building code. Against this background, I'm convinced that it will be very interesting to learn more today about Washington State's energy code that requires building electrification. Germany is home to a lot of innovative companies working on technical solutions for the building sector. I'm therefore convinced that today's event will provide a fantastic opportunity to explore potential for cooperation between these companies and partners in the United States. Without further ado, I'm going to hand it over back to Cora and the rest of the organizers and wish you all a very interesting and inspiring event. Thank you so much.
Thank you, Mark. Now it's time for our first keynote. Please welcome with me Carrie Mead, Executive Director at the Northwest Energy Efficiency Council and the Smart Building Center. She specialized in environmental policy and holds a master's degree in public administration. She also volunteers as a board member of the Seattle 2030 District Organization and serves on the Seattle City Lights Review Board. Her extensive environmental policy experience and skills make her an important figure in the Seattle and Washington State energy efficiency landscape. Carrie's area of expertise include utilities, P&E, process improvements, and research and policy analysis. Her goal is to improve the sustainability, safety, and efficiency of the buildings of the future to effectively address climate change. Please help me welcome Carrie.
Thank you so much, Cora. It's such an honor to be here. I'm so excited to be a part of the conversation, and I'm really looking forward to hearing what all the presentations to come will cover. Let me just share my presentation. Okay. And please go ahead and stop me if there's any issues with audio or anything like that. So as Cora just said, my name's Carrie Mead. I'm the Executive Director for the Northwest Energy Efficiency Council and of the Smart Building Center. And I want to talk to you today about the essential role of smarter buildings in supporting our transition to clean energy. There we go. So a little bit about who we are. NEEC, the Northwest Energy Efficiency Council, we are a nonprofit business association. We represent businesses in the Pacific Northwest who deliver energy efficiency into buildings and sell energy efficiency to the market. We've been doing this work for over 20 years, almost 30 years. I've been a part of NEEC since 2017 when I took over for its founder and former executive director, Stan Price. The mission of NEEC is really to advocate for programs and policies that promote energy efficiency for the benefits that it brings to the economy and to improving our environment. NEEC is partnered with the Smart Building Center. The full name of the Smart Building Center is the Smart Building Center Education Program, the SBCEP. And this is a nonprofit charitable organization with a mission to accelerate the adoption and commercialization of smart building practices and technologies through education and demonstration. The Smart Building Center Education Program was started about 5 years ago by a few individuals who are working in the smart building space in businesses. And so we partner with industry to achieve our mission. The Smart Building Center pursues that mission through 3 pillars of activity. The first is to train the workforce for the future. We have the Building Operator Certification Program. The BOC program is a training program for facility staff working in buildings. We train them in how to efficiently operate those buildings, and that's offered nationally through our partners, and then we administer it in Washington, California, and the Northeast. We have a robust website, thesmartbuildingcenter.org, where we offer educational resources. We host technical webinars. We invite folks to present on tools and topics that are technical in nature, excuse me. We have a YouTube channel with training videos and other content. We have various help desks. One help desk we've been running for over 10 years for the city of Seattle related to its energy benchmarking ordinance. Then we also seek to demonstrate smart technologies and practices. So we have a tool lending library, which we classify as sort of demonstration of technologies, where we loan out building diagnostic tools for free to folks who work in buildings who want to measure the performance of those buildings or address other issues inside the building. Pre-COVID, we were hosting building tours, take folks to see actual smart buildings and projects out there in the world. And we hope to get back to that soon. And then we have a physical space in Seattle where we look to curate and demonstrate technologies in our own space. So to have efficient and smart technologies there. Let me move, I can't see my slide. Oops, well, hold on, one more thing. Lastly, we convene the industry through hosting and participating in events. We have, like I said, we have a space that folks can use for free to host their own events. We host educational forums. They're short events in person or virtually, where we bring together senior executives to talk about relevant topics to smart buildings. And then lastly, every year we have a conference, an annual conference, which is usually 2-day conference. This year we did 3 days, where we convene folks from all over the world actually to talk about smart buildings and address challenges and opportunities, to look at case studies and sort of to push the industry forward. So today, what I'm going to talk about is really transformation. The whole time I've been working in the energy space, it's been undergoing transformation. I started working in energy efficiency straight out of graduate school in 2009. And the way things were done then is vastly different from the way they are done now. At the time, the focus was really on energy efficiency for its benefits to the grid, for its savings to its customers, and all of those things still apply. But we didn't really talk a lot about climate change, and that has really changed. I think a lot of the discussion now, rightfully so, is focused on greenhouse gas emissions and how we can address global warming. So this isn't a topic that is new at all. We've known that the climate is warming for my entire lifetime, and we've known that our own activities, the emissions that we generate through our activities, are warming the climate. So what is new is that I think there is a renewed or a new focus across the globe, and certainly here in the US, it's fairly new, to really address this issue. And the reason is because the climate warming, we know, is going to have terrible effects on sustainability of life on the planet and just the quality of our life in the short term. And we also know that the warming is accelerating. And so in the simplest terms, we can stop global warming when we stop emitting greenhouse gases. And when we do stop, we're going to stay at the level of warming that we have, achieved. for quite some time. And so that's what this graph is saying. We all hear these numbers all the time. So the goal, right, is to stop the warming at 1.5 degrees. And that's sort of this bottom line here. And if we stop there, you'll see we're going to stay at that warmer level for quite some time, but we won't continue to grow. And so then the question from a policy perspective shifts to, okay, so if we're going to stop emitting greenhouse gases, we need to look at where those emissions are coming from. So in the United States, the largest source of our emissions is transportation and buildings. And here I am grouping buildings. I'm sort of taking electricity generation and assigning it to buildings. And that's because the vast majority of electricity that's generated, it's to service buildings. I think it's over 70% of electricity in the US is for buildings. And then you also have on this graph the orange and yellow I don't know, lines, I guess, at the top of the graph. And those are end uses in buildings where we're directly burning fossil fuels. So usually that's space and water heating. So that's also emissions that are coming from buildings. So you have 70% of the pink piece, and then all of the orange and yellow, that's all building emissions essentially. And then we also have transportation. And so the focus really now is on, is there a way that we can address these categories of emissions through cleaning up the electricity supply and electrifying those end uses that aren't currently relying on electricity? So that's where we, talk about electrification of transportation. Let's bring all these EVs and replace our gas-powered vehicles. And then let's take these orange and yellow lines and let's electrify those end uses as well. And then we can really focus our efforts on just generating power that's cleaner. So cleaning up the supply of power to our electrical grid. And if we can do all of that, we can clean up a tremendous amount of the emissions in the United States just through generating cleaner power and electrifying all of those end uses that we can electrify. So just to look at this a little more closely, we can look at Washington State as an example. I think it was 2020, we passed the Clean Energy Transformation Act. This is also sometimes referred to as 100% clean. So this is our bill that is going to push our electricity to 100% clean power sources by 2045. We're working on that now, and that's awesome. That will take us a long way there. We also have in the state, we have these were referenced earlier in the opening remarks, but we have our greenhouse gas emission targets. So in the short term, we are looking to reduce our emissions over our 1990 levels by 45% by 2030, and then by 95% by 2050. So we have the target of getting the emissions down by 95%. And then we also have this bill that's looking to clean up our power. So now what we really need to do is just look at how we electrify things and what that will mean for us. And so in Washington State, our energy strategy, the 2021 energy strategy, recommends electrification as the least cost pathway to decarbonizing the building sector. And so what will that mean for us? Essentially, it means that we're going to double our electricity load by 2050. So that is no small amount of load growth. We're looking in the short term at 13 to 20% of our load growth over our 2020 levels by 2030. And then that's going to accelerate, and we will be at 92% above our 2020 levels by 2050. So that's above essentially where we are right now. Basically, we're going to create another grid in terms of the load. So that's, it took, this is another little blurb that you hear thrown around, but it took 140 years to build the current grid. And we're in 30 years, we're going to fix that one up and build essentially another one. And so that is a major undertaking. So then we're really thinking, okay, if we're going to actually be able to clean up our power and accomplish this, we're really going to need to bring every technology to the table that we can. So on the supply side, we need every possible clean resource that we can think of to be considered. And on the demand side, we also really need to look at the efficiency of our buildings, and also just the actual technologies that are inside those buildings, and what we can do to advance smarter buildings that can really manage that load growth, and perhaps lessen it a little bit. And so again, that was also mentioned in the opening remarks. Efficiency is an essential part of this transition. So that's where we get to buildings as enablers. So if we are looking to double the size of our load in Washington state, that's going to be extremely costly, but technologically how are we going to accomplish that? And so what we really need to do is look at the buildings. I mean, we need to do a bunch of things on the supply side as well, and on the transmission and distribution system. But we also need to look at these buildings themselves and see if there are ways that we can mitigate some of that growth, and also ways that we can put smarter technologies in place that can take the buildings from sort of, I don't want to say stupid buildings, but buildings that just have one-way communication with the grid, to buildings that can communicate in two directions. So what this graph is really showing is installing a suite of connected technologies inside the building that communicate with the grid and with one another, and with occupants, and can manage dynamically how the mechanical systems are functioning inside the building. We also need to look at battery storage. Some of these really lofty thoughts that are seemingly not as far off in the future as they once seemed, but is there a way to take advantage of our electric vehicles that are sitting idle in our parking garage and their batteries are sitting there? Could we possibly be storing and leveraging some of those batteries and timing the battery charging in a way that's beneficial to the grid? Can we also look at on-site generation? Can we put on-site generation on these buildings and use that for the building itself, and potentially communicate with the grid about sharing some of that power if it's needed? So there's a variety of things we can do to make these buildings smarter, to make them grid interactive, to time the use of our technologies inside the buildings, our mechanical systems, to become more flexible, and to sort of adjust our operations in communication with the grid. And this graph here on the bottom, which is from Kara Carmichael at RMI, it shows kind of the consumption curve of a typical commercial building is the first little box, the blue one. Then you see that you can lower that curve, but you still have the peak in the center when you install energy efficient equipment. But if you then also have some solar PV or on-site generation, you can actually really pull off the grid during the peak and maybe rely on your own power. And then when you have grid integrated building with energy efficiency, solar PV, and other load flexibility strategies, you can just take that curve, flatten it out, and it becomes much more predictable and useful to the grid, since peak issues are certainly going to be part of the challenge with this transition. So I'm almost out of time, so I'm gonna just last slide. I want to say this is also going to save us money. So it's not just going to save energy, which the U.S. The Lawrence Berkeley National Laboratory estimates 29% of on-site energy consumption could be saved. It's also estimated to save us $100 to $200 billion in electric power system costs. So this is it's a big deal. This is a quote from Seth Cohn at RMI, and in the interest of time, I'm not going to read through it, but it just talks about the essential nature of smarter buildings in supporting our transition to clean energy. And that is the end of my presentation. Thanks so much for having me, Cora. It's been a joy. I look forward to hearing the rest of the speakers.
Thank you so much, Carrie, for your insightful keynote and for highlighting the issues and the possibilities in Washington. To now represent the German perspective, we will hear from Constanze Adolf, senior partner at the Berlin-based consultancy Christ & Company. She's involved in setting up the new Energy EU Affairs division to support companies in their transformation on topics relating to energy and climate policy. After completing her doctorate, Constanze Adolf was Secretary General of the European Union Federation of Youth Hostel Associations and Executive Director of Green Budget Europe. Most recently, she was head of business development at the energy storage startup Luminium in Berlin, and there she helped drive the market ramp up for high temperature steel storage technology and was in a leadership position for the thermal energy storage working group at the Federal Association for Energy Storage Systems. Constanze, the floor is yours.
Thank you so much. I will try to bring up my presentation. I hope everybody can hear me. Good morning, good evening, everybody. So here we go. Right. Carrie, great thanks for your exciting presentation. I love this term of buildings as an enabler. And I would like to bring you some slides from a German perspective about electrification and how this could enable decarbonization, specifically in the energy sector. So what do I want to talk about? First of all, kind of the role of electrification in the current system. You might be all aware that Germany and Europe at the moment has got high challenges in terms of the energy transition because of the war in Ukraine and between Ukraine and Russia. So you can see on my second agenda point, there is a question mark at the end about the current challenges in Germany to decarbonize the building sector, because my hypothesis is that in the end, it's not a challenge, it's also a huge opportunity that we have at the moment to really decarbonize and to switch to more decarbonized technologies. Then I would like to bring you some theoretical development in the housing sector and then get to my former job. As mentioned before, my former job at Luminium was to build to help building high temperature storage system specifically for electrification in the residential sector. And I would like to bring you one of the examples from Berlin. As mentioned before, I'm here on behalf of the German Energy Storage Systems Association, BBES. It's an association of more than 250 members, and I had the big pleasure to lead the thermal energy storage working group there. The great thing about the BVES is that they are really not technologically driven, but that they are bringing together all different companies from the industry, from utilities, from the grid operators, as well as insurance companies and investors. And this makes a very special setup to really look at the entire system, something that I appreciate a lot. The main focus is on advocacy. We had a huge success this year in terms of advocacy for energy storage systems, because in Germany, for the first time ever, we had a quite comprehensive definition of what storage actually could be, and that really drives the regulatory phase at the moment forward. And then there was also a huge chapter on research and development within the BBAS. And yeah, last but not least, this is my daily business at Christ & Company at the moment here as a consultant to shift kind of, or to help industry to shift to decarbonization. Now, what are the current challenges? I mentioned this before, this is nothing new for all of you. Not only because of the very current this year challenges that we have in the system, we have significantly rising energy prices, be it electricity, be it natural gas, or be it oil. And then there is a second one, which you can see here on a more longer perspective. The more renewables we have and the more renewables are penetrating into the system, the more volatility we have on prices, as well a huge challenge for a lot of players. And last but not least, something that we had for the last 15 years or so. We have a rising CO2 prices, and you can see that for a long time our the carbon price was very low. It was kind of sleeping, but now we have also here some more challenging regulations that brings the prices closer to what the real cost of 1 ton of CO2 are. So at the moment you can see 1 ton of CO2 costs at the moment 71 euros, makes it roughly $70, whilst the real societal cost behind 1 ton of CO2 would be around 200 euros, so roughly $200. So here you have got the main sectors of energy in Germany. You've got quite a high level of penetration of renewables, so 41% in electricity. The second one, here you can see the dinosaur. We have only 16% of renewables in the heating and cooling sector, and a lot of energy is used in the heating and cooling sector. So as an industrialized country, Germany uses more than 50% of its energy in heating and cooling. And as what you can see here is the huge opportunity to decarbonize, because at the moment we are only at 16.5%, even less, only 6% in transport. Now, what we have is we have this huge challenge to decarbonize. We have some new regulations that wanted to bring Europe as well as Germany to a carbon-free Europe, not only by 2050, this is EU, but Germany said to 2045, and in the electricity sector, possibly even by 2035. And here, with the penetration of renewables, we see a huge also need for more storage systems. Something that you can see here. So at the moment, we've got a 2045 target for 100% renewables. But if we bring this to 2035, you can see that the path is somewhat different. And this is why we need to really speed up here. How do we want to do this, or what is the kind of the pathway? Well, we started quite soon in 1990 already to bring the first renewables into the system. We are now in the second phase where we really need to integrate this systematically in the energy system. It's to deal with the slides beforehand. So you need a lot of flexibilization because you have this volatility in the prices. You've got some hours per day where you have a lot of sun shining, a lot of wind blowing, but can we do this, and how can we really elongate the phases of getting electricity, and how can we best integrate this? We will go further to in the third phase to more kind of synthetic fuels, and then looking into how we can build up a 100% system. What you can see here at the moment is that we really have to change our regulatory framework as well to allow those technologies to flow and to do their work. So here you can see a first, let's say, a first success. So the first phase of our system was to decentralize in a way that beforehand we have in the fossil power plant land map on the left-hand side, you can see some very centralized power plants, very easy to regulate from the system perspective. On the right-hand side, you can see already today how much kind of decentralized energy systems we have. A lot of wind in the north, a lot of sun in the south, and this needs to be integrated. How can we do this? As I said before, and I think this is something common ground: decarbonization, decentralization, and digitalization, with this huge need to make the local availability. As I said beforehand, you can see we have now electricity everywhere, but the local availability needs to transform into temporary availability. So to really look into having your electricity anytime available. And this is where storage comes in. Now, in the next chapter, I would like to illustrate this a little bit more. So you can see here on the left-hand side, the day, you've got some solar panels on your rooftop. While the sun is shining, you can kind of fill in your batteries, you can charge your batteries, so that in the nighttime on the right-hand side, you can then decharge your batteries and provide your house with electricity, also with heat, if you, for instance, have a heat pump. And this is something that we can see now very much a huge market in Germany as well as in Europe. So there is a huge switch from getting kind of independent from the grid. So self-consumption is the huge word for this. With self-consumption, meaning you are dependent obviously on when the sun is shining and where the sun is shining. Self-consumption meaning PV on your rooftop plus batteries means you've got a lot of more opportunities to really make use of your electricity whenever it is needed. And this now also in a more integrated view, we had seen this, I think, also with Carrie, you have your heat pump, you have very interesting now, the digital kind of gadgets that help you to process and to think of how to make best use and optimize the different energy flows in your houses. And on top of this, we also have obviously now coming in a lot of e-cars, something that was very slow in Europe and specifically in Germany, with a huge car market in Germany that was very resistant against e-cars. But now we've got a lot of electrical vehicles in the grid. And this is in a way the future. I think something that is very useful is also looking into bidirectional charging. So to really make use of your car as a huge battery as well. And then you can also obviously couple different houses for having a kind of virtual power plant, something that is also coming more and more. And we've got this wonderful new regulatory framework that allows us for peer-to-peer marketing, which is also very good to really get this kind of independency. Well, my last slides are now from the very, very practical way. I would love to bring you back to my former company, which is Luminion. What they did was a power to heat steel storage system. It was a thermal storage system. So looking into how to make best use of this peak hours of electricity, storing this electricity into a huge steel storage system, and then decharge it as heat or even steam for industry, as well as the possibility to use a steam turbine to then re-electrify the whole thing. Why is this a good business case? So at the moment we've got a 532% energy price increase. So this is only electricity. But with the system that I just showed beforehand, you don't care about this. This is why I think, again, there is a lot of at the moment of anxiety within the society, because nobody knows how to get electricity and how to pay your bills. But with such a system, you can make yourself independent because you don't depend on the high prices. You look at the low prices, and you can even earn money with your system. As you can see here, we had here some negative prices. So what you do with the system is you charge during the 4 low time or low cost hours per day, or doing 2 days, 8 hours. And you don't care about the high prices, you only care about those low prices. And that means that you can save a lot of money, not to speak about CO2. Here's a second argument for the business case. We have a lot of curtailment in Germany because our grids can't kind of take all the electricity that is provided. And that means we have a curtailment of around 6 gigawatt hours per year. And at the price of 500 euros per megawatt at the moment, you can see there is a lot of things you can do. So this is the thing in practice. This steel storage system, you can see in the front, you can see the heating system, and then in the back, the gray part is the steel storage itself. This one has got a capacity of 2.4 megawatt hours. It heats around 600 houses here in Berlin. This was a very brownfield project. There was a CHP plant beforehand. Now it is replaced by this system to be carbon free. It's a first project of this kind, and it runs now still from 2020 onwards. This is how it works. So you have on the right-hand side, you have the van that blows some air through the system. On the bottom, you've got the heating elements. So the heating elements are heating up this air. The air gets red, so meaning hot, to 500 degrees. Those 500 degrees heat up the steel, and the steel now takes this 500 degrees until you decharge the system, meaning whenever you meet the heat. And so you've got this kind of round and the circling. It's very simple, but very effective. So you've got an efficiency of around 95%. And why is this all interesting? Because I think if you look into those challenges that we talked in the first slide about rising energy prices, so you can get independent from those rising energy prices, not only because you get independent from the grid, but also because you can produce and use your own electricity whenever needed. You can use those systems for bigger houses or even some quarters. You can also use this for industries, and you've got your backup energy whenever it needed. So I think with further ado, I'm definitely over time, but I'm very much looking forward to our discussions later on, and this as maybe the conclusions. So I'm very happy that now Germany started to really think in a more systemic way that we can integrate energy storage into the system because of new regulation. We need much more of this, and what we need is also a lot of communication because, and I think this will be a very interesting discussion point later on, it's not about technology. I think we all have the technologies that we needed, and we have got very research-oriented kind of departments that will help us to improve and to optimize those technologies and to bring in more technologies. I think it's a lot of psychological facts and factors that will need to help us to bring further where we want to go in terms of decarbonization and decentralization in the system, which makes it more robust, obviously. So this is me. I'm very much looking forward to the discussion later on, and thank you very much for your attention.
Thank you, Constanze, for this great overview and for showing us what we can expect from the German side. I'm now going to turn it over to our German companies who since the beginning of this week have been meeting with building efficiency stakeholders across the West Coast, learning just how much potential there is. We will start with Ian Nemo, product consultant and representative for Lunus Lufttechnik. Ian, please go ahead. Ian, you're still muted. Ian, can you hear me? You're still muted.
Okay, perfect. Can you hear me now?
Yes, now I can hear you.
Okay, great. Sorry about that. All right, well, welcome to my presentation. This is Lunos, the answer to decentralized balanced heat recovery ventilation. I'm a product consultant at 475 High Performance Building Supply, and we are the exclusive distributor of Lunos systems in the USA. And 475 is built as an e-commerce business. You can order products and arrange shipment directly online across the United States and Canada. And our website is a source of diverse knowledge in addition to great products like Lunos. Now, you all know what a stuffy home feels like, right? Trapped air in your home that may smell musty and feel stale. How about a cold, uncomfortable, and drafty home? Typical exhaust and CFIS systems are inefficient and can create uncomfortable and polluted conditions. Exhaust-only systems depressurize the home, bringing in unfiltered and unconditioned outdoor air, creating health, comfort, and cost issues. They also don't reliably ventilate every space in the home. Typical CFIS systems distribute air well throughout the house, filter the air, and can condition the air before it gets into the home, but it's not an energy efficient option. Heat recovery ventilation provides the best benefits by distributing fresh air to the entire home, filtering the fresh air, and using heat recovery to optimize energy efficiency. HRVs and ERVs are also typically balanced, meaning they don't pressurize or depressurize the home, adding additional benefits. And because air tightness is the greatest factor in building energy use, building codes are pushing for higher and higher levels in residential and commercial construction in order to make homes more comfortable and energy efficient. So now we must design, invest, and install mechanical ventilation. Heat recovery is optimal because you don't waste energy reheating or recooling the air, and the heat is transferred using a heat recovery core. Lunos is uniquely poised to meet this need. Lunos was started in 1959 and currently has 115 employees and is the market leader in the field of decentralized home ventilation. They're based in Berlin, Germany, and they distribute to 36 countries worldwide. Keep in mind today that I will be using the term decentralized when talking about Lunos. Decentralized means no ductwork and no large central fan. Here you can see what a centralized system typically looks like, with ductwork running through the conditioned and unconditioned spaces in the attic, ceiling, and framed walls. These are great systems, but they require more design, more labor, and more commissioning of the system to ensure it's operating effectively. Lunos, on the other hand, is your ductless through-wall solution. It's an excellent choice due to its low energy consumption, quiet operation, high heat recovery efficiency, its serviceability, and its flexibility. Unlike centralized systems, there's no ductwork or large central fans that must push air throughout the entire home. Instead, the Lunos is installed as a single unit or pair, one fan supplying fresh air while the other exhausts stale air. In addition, Lunos operates up to 89% heat recovery efficiency, minimizing comfort issues and wasted energy. Lunos E² and E²60 models operate as pairs. As one fan draws fresh air in, the other exhausts stale air out. The fans alternate direction every 70 seconds in order to transfer the heat to either the incoming or outgoing air through its ceramic core. For example, in the wintertime, when you have warm air inside the home and cool air outside the home, as air is being pushed outside the home, you have warm air moving through that ceramic core, preheating it. After 70 seconds, the fan switched directions. Now the fan that was exhausting is now supplying, and cool, fresh air is coming over the ceramic core and being preheated by it before it moves to the interior space. And the Lunos E² system can move up to 35 cubic feet per minute per fan pair. So here we see an example of how air moves through the home with Lunos E² or E²60 models. As we said, they don't have ductwork, so they rely on pressure differences inside the space to move that air. So as you can see in the bottom of the picture, we've got air being pushed in and then air being pulled out at the top, which moves air throughout the home. After 70 seconds, you get air moving in the opposite direction, with the bedroom being positively pressurized, the living room being negatively pressurized, moving the air from one space to another. The Lunos E² and E²60 also have a summer ventilation mode where the fans run in one direction and only switch directions every 60 minutes. This allows the Lunos fan pairs to bring in cool outdoor air overnight to pre-cool the interior space, essentially acting as a whole house fan and reducing cooling costs in the summertime. The Lunos Ego is a single through-wall unit that has two fans within the same housing. The Lunos Ego has two modes, heat recovery and exhaust only, offering a great option for bathrooms or small spaces. And it also offers up to 85% heat recovery efficiency. So just to recap how Lunos operates, the fans run continuously 24/7. They work in counterflowing pairs. The system is balanced with one fan exhausting and one fan supplying at the same rate, preventing pressurization issues. The ceramic core transfers the heat to maximize comfort and performance, and Lunos provides ventilation to the entire home. They're very flexible and simple. They run on low voltage, 12-volt DC power, and there's really no tools needed for any type of maintenance. You can pull the fan right out of the wall, inspect it, clean it, change the filter, all of that stuff. So they can also fit in any size project, from multifamily to single family, new construction, renovation projects, and low energy and passive house buildings. As you can see, they're very discreet and can be installed virtually anywhere in the home that is aesthetically pleasing and functional. The diameter of the Lunos fan tube is about the diameter of a DVD or a CD, if you remember what those look like. And Lunos does offer up to MERV 13 filtration, which offers the best protection from outdoor pollutants such as pollen and particulate matter. MERV 13 filtration is very important because it eliminates up to 90% of PM 2.5, which is the dominant particle size from wildfire smoke. Lunos also offers robust exterior covers like the outer hood with sound absorption. It's made from aluminum, can be painted, and offers the best protection against the elements. And here at 475, we can help support the design of your heat recovery ventilation system as well, depending on the layout of your building, required ventilation level, and site-specific conditions. As you can see here, 3 pairs could provide up to 105 CFM of ventilation, which is going to satisfy most buildings. So that's it. Thank you so much for joining me today. Please write down my email address, which is ian@475.supply. I would be happy to connect with you, and thank you for your time.
Thank you, Ian. Next, we will hear from Günther Klee, CEO and founder of LED Light Germany. Günther, please go ahead. Günther, you're also muted.
I see it, sorry. So my name is Günther Klee. I'm the CEO and founder from the LED Light Germany. Please, next slide. LED Light Germany is high-performance technology is designed and developed in Germany. We are specialized manufacturer for lighting and interior. The lighting and the interior and service offers are tailored to the respective customer's needs and the projects. We are a system partner for energy efficient lighting system and renovations with the highest possible quality and service processes. Die LED Light Germany, wir machen projektspezifisches Geschäft, das heißt also, wir gehen in die Projekte rein, schauen uns die Projekte an. We go in our projects, in all the projects and we made there together with our customers the analysis and about these projects, and this what the customer need, we produce. So we have not only based on the catalog and you search what you want. No, we go in the project, check the situation with the customers together, and about that we create our lamps. We equip also our lamps with an antibacterial and germ-free concept, and also the buildings. We also provide hospitals, schools, kindergartens with antibacterial light concepts, plus a human-centric lighting. The human-centric lighting concepts is also for food and for the clean room industry. We can use our light in the architecture, monuments, public areas, landscape lighting, sports and event halls, places, theaters, conference and expedition halls. Next slide, please. These are some of our unique selling points. Research and development in our house since 2006. We have 5 color systems since 2009. We have not binning in our lighting. This means all LED lighting, all colors are same. We have 10 LEDs, so it's much more, and all the LEDs looks same the others. We give up to about our experience. We give up to 10 years warranty to our lights. We use high quality material. And about that, we can make all our lamps with passive cooling. We use, made in Germany, also high reflecting reflectors with special facets and surface structures. With them, we can make a Garant homogeneous illumination. We have an absolute modular system. With them, we can go near all places to bring the light there. We have a cradle-to-cradle system. This means if some lamps from us go down, you give the lamp back, you get direct a new lamp from us. And after that, we make a refreshing from this wrong lamp and bring it back in the resource and the sales circle. We have a permanent protected antibacterial and germ-free lighting and also interior. Next slide, please. The target person, what we are looking at, hospitals, schools, kindergarten, operators of hotels, and all these parts, what you see on this slide. Next slide, please. This is the Camera Grand. This is the first project what we do after our start in 2006. Also 3 years after our research and development, we start with this big project. Next slide, please. This Camera Grand. What you see is an event hall with 2,700 square meter. Planned was There are 35,000 watt halogen high day lighting and only white light on off. We installed there 5,000 watt LED lighting, but we daily in the operation, we need only 1,400 watt in 25 meter ceiling height. Plus, we give them a full color light system so that they don't need event companies to bring the color light inside. They switch the button from our systems there and can use the whole in the full color system. Next slide. This is the Kamiak, is this the Humboldt Carré? It's the same owner. After this Kamiak, we make this project. This is in Berlin. This was 2011, the best location, what hall, what we have about our lighting. We see outside. Next slide, please. This looks inside the conference hall. Total what you see with 600 watt LED in the full color system and control with the DMX full control system. Next slide. This is Kursaal Bern is one of the popularest and largest congress houses in the Switzerland. Next slide, please. This is the Titanic Deluxe. What you see here is the best way to show good light and bad light, because we lose the project inside. The inside lighting, we make only the facade. The facade have 150 windows, and the total facade, what you see, have complete 100 watt only. 120 watt only. This means each light what you see, we drive with 0.8 watt. An absolute homogeneous, and inside you can see the front lighting, because the problems of the cheap Chinese material, what most times used, you have a very dark binning. This means if you have 20 white color chips, you have 5 different colors there, and did you see on display is very good. Next slide, please. This is one of the biggest projects that we do also. This is one of the biggest and largest force what we have in Europe. We make all the lighting there. And what you see, we make 12 meter ceiling heights only with a LED stripe from us. Next slide, please. This is also the Hambacher Castle. This is the popularest forest what we have in Germany. The German democracy is created there. And what you see in the middle, this restaurant, alone this restaurant, what you see the lights on the roof, the complete restaurant, we work only with 41 watt. There's 41 lamps, and each lamp, what you see, they have only 1 watt total system power. Next slide. Next slide. This is a battle, LED light Germany to LED light to Germany, as 2 German companies in the battle there. First time was a competitor from us. They installed this 2011, but they have a lot of problems there with foul lightings. And after 5 years, the government speak, they must stop this, and we changed this. And what you see here, how much what we save about the competitors to us, and also you can see how much money we can save there also. Next slide. This is the last what we do now in Dubai, in Sharjah, is a monument with 36 meter ceiling height and 20 meter in the diameter. Next slide. So we have a full
unfortunately, I have to interrupt you here just to give the rest of the speakers enough time as well. But thank you so much for your presentation. If anyone is interested in meeting with Günther or wants some more information, we are happy to connect you. So thank you. Last but not least, we will hear Stefan Göbel, Business Development, North of America from Priedemann Facade Lab. Stefan, please go ahead.
Okay, thank you. Thank you so much to the German American Chamber of Commerce for having me. My name is Stefan Göbel. I'm charged for business development for Priedemann in North America. And today we'll talk about the ACT facade, the active cavity transitioning facade. Very quick introduction here. Priedemann was founded in 1993. It's 157 architects, engineers, facade designers, headquartered in Berlin and present globally. We're used to energy efficient buildings. We've designed a lot of them here in Germany. We know high-rise from the Middle East, and Briedemann has done projects in North America as well. Briedemann supports the investor, developer, and the architect during the early design stages of the projects, but then also can follow through with engineering services to the general contractor and fabricator. And there's a close collaboration with the industry, particularly with our R&D lab, and always having the user in mind. Now, it's important, one reason I show this is because when we think about our climate crisis and the challenges that we have ahead, we need to make sure that we bridge this gap between design responsibility and execution responsibility, because it doesn't really help us if we design and model efficient buildings, but then they're not executed well. So I think that's where Briedemann is unique position, because we are following along that entire project chain. I want to show you one example here, the Festo Automation Center. Festo is known for its innovation in Germany, and they wanted this traditional glass cube building, but they wanted it to be DGNB Platinum certified, which is very similar to LEED Platinum certification. And there's a category, it's the atmosphere, energy and atmosphere category, that makes that very challenging for a building like this all glass building. So Briedemann approached this project and looked at many different facade types, closed cavity, double skin, box type facades, but all of those really didn't meet the either design intent of the project or the energy efficiency, or there was just way too much material from a life cycle perspective included here. So because of that, Briedemann and the project team developed a new facade type, the active cavity transitioning facade. I want to show you this short video here. We see a traditional office tower and curtain, unitized curtain walls being used here. What you see here in a second is the air supplied in the center of the room. And then as soon as the facade is exposed with sunlight or solar radiation, this tightly integrated reflective blind will come down, and the air is exhausted through this 7 to 4 inch cavity. It will heat up to 86 to 95 Fahrenheit. And then it can be used through a heat exchanger, or it can be exhausted. And so that hot air and that solar radiation is not penetrating into the interior of the room, and thereby reducing the cooling loads dramatically. To get to that kind of efficiency, in comparison, we would have to use a double skin facade, which takes up a lot of space, rentable floor space, but uses a lot more material from an embodied carbon perspective, not that great. Same with the closed cavity facade as well. So this type of facade was tested with the Fraunhofer Institute, and in a twin room that we see on the lower right side here, there were 25% cooling load reductions achieved, and this building has achieved their DGNB Platinum certification. There's many other buildings that are using it. If you're ever in Berlin, please come visit Briedemann's Briedemann in the south of Berlin. Here, there's many different mock-ups. One of them being the ACT facade compared to the double skin facade and other facade types. Here is just an illustration of the space savings, approximately 25.5 inch that we're saving with the active cavity transitioning facade to get to a similar performance to, that a double skin facade shows all the way on the left side, but it uses a lot more space. This kind of approach and concept was used in the ADEX Tower here in Witten, and at a project at a Euro Tower in Frankfurt, where this building was supposed to be upgraded to a later energy standard. And there were the idea of tearing down the facade and refurbishing it. However, Briedemann and the project team came in and really upgraded level by level with this tightly integrated blind and the ducting. And you can imagine the downtime if you're tearing down the facade versus you're just touching the inner layer of the building. So there's a lot of time savings. It's kind of hard to read here, but from a cost perspective, at the time was about an 850 euro, which currently is about an 850 US dollar per square meter. So that's about 10, that's about 85 per square foot. Sorry, $85 per square foot. And if you have any questions on this, please reach out to me. I can give you some more information on this. But we're comparing this to a double skin facade, which is about $1,200 US per square meter. So there's a saving here as well. This is the project team, Briedemann as the facade consultant, Transolar, Schüco, facade system, and Varima, the custom designed appliance that we used here, and then obviously the Fraunhofer Institute. And thank you for your attention. Please let me know if you have any questions. Happy to answer those.
Thank you, Stefan, and thank you again to all the German companies for presenting today. I'm very excited to now move on to our panel discussion, which will talk about electrification and what has to happen in addition to it to transform buildings. The panel will be moderated by Emily Salzberg, Managing Director for the Building Standards and Performance Unit at the Washington State Department of Commerce, where she currently oversees administration of Washington State clean building laws. Emily has over 15 years of experience administrating, evaluating, and providing technical assistance for energy efficiency programs in the Northwest. Her experience includes low-income weatherization, community-based efficiency programs, technology research, market development, and energy code implementation. Emily, I will now hand it over to you.
Thank you so much, Cora. Quick audio check. Can you hear me okay?
Yes, we can hear you.
Okay, wonderful. All right, thank you so much. Hello, everybody. My name is Emily Salzberg. As Cora mentioned, I'm the Managing Director of our Buildings Unit here at Department of Commerce. So we're the State Energy Office here in the state of Washington. I'd like to thank everybody for having me here today. I've been asked to moderate today's panel discussion focused on transforming the built environment. Buildings are responsible for roughly 1/4 of greenhouse gas emissions, and they're one of the fastest growing sources of emissions. Today's discussion will focus on the benefits of electrification and how it can be combined with other solutions such as smart technology, demand response, and energy management to decarbonize the built environment. We've assembled an incredible panel of experts, and I've asked everyone to provide their own introductions and a brief overview of their work and their organization to get us started. Each panel member is going to take about 5 minutes each, and then we'll shift into the discussion portion of the panel. So Angela, would you be willing to go first?
Sure. Can you guys hear me okay? Great. I'm actually in Phoenix right now at the Building Commissioning Association conference. So I have a different background than I usually would. So I was just checking all the camera things. But yeah, I'm Angela Templin, mechanical engineer by training. But I learned that if my electrical stuff wasn't powered up, my gear never worked. So I started getting into electrical engineering, started working on controls, really working with the owners to make sure that the facilities really work how they want it and that they understand how things are supposed to work. Because that kind of comes down to some of the crux of it. If they don't quite understand why things are doing what they're doing, they won't really know how to operate things properly in the future. So when I started looking for work beyond my mechanical engineering degree, I started looking at the commissioning industry, and commissioning is really, if you guys were on that previous, where the kind of that barrier between the design and the implementation, and making sure the design intent is really coming to fruition with how the building is controlled and all the different systems are controlled. I'm part of GLUMAC. We're a mechanical, electrical, plumbing engineering firm with sustainability, energy analytics, and commissioning. That probably wasn't your 5 minutes, but it's my quick spiel.
No, that's great. Thank you, Angela. Colm, would you be willing to go next?
Absolutely. I will even unmute my mic. Hi, everyone. Colm Otten. I am currently a portfolio segment manager at Seattle City Light, which is Seattle's electric utility. The portfolio that I manage is a portfolio of energy efficiency programs where we provide incentives to our customers to install, improve, or replace their inefficient equipment with more efficient equipment. This is really important to us as a utility for many of the reasons. Probably the best illustration was given by Carrie, where she showed that our grid is going to double in load in the next 20 to 30 years. And we need to have the capacity to take on that load. So energy efficiency is the cheapest way by far to do that. And I am here to help our customers, and my entire team is here to help our customers make those changes. Probably a little background for how I got here. Angela did a very brief version. Mine might be a little bit longer. I grew up in Belgium. So guten Abend, Damen und Herren. Klein bisschen Deutsch, but I'll leave it at that. Flemish, my primary language, and English secondary. I grew up in Belgium, got an engineering degree there, landed a job designing engine parts for Formula One racing cars. So actually, I was in Germany quite a bit with the Toyota Formula One racing team back in the late 90s, early 2000s, and really learned the value of integrated design. A small part can make a big difference if you understand how all the pieces fit together and what it is that you're trying to achieve, and that we're all in this together. Like, we have to work as a team. These are really important lessons when you take them into sustainability, which is where I went to after Formula One. Got a sustainability, sustainable design degree in Philadelphia. Landed in Seattle doing some commissioning work, like Angela is doing, as well as some design work, where I really learned the built environment and how buildings operate both individually and as parts of the grid. And all of those lessons I am now applying in my current position of trying to help the entire region transform and move to a future that we are all hoping we can get to.
Thank you, Colm. Constance, you willing to go next?
Well, I think I had the big pleasure to already present myself more or less. Maybe about myself, as you can hear, I'm very German. I lived in Brussels for quite a long time, and I tried to influence there and did a lot of advocacy work on our current regulatory framework in terms of energy and climate. And this was quite interesting because I think, and this is why I liked also this event, because obviously climate change doesn't stop at national borders, and we have really to think about how to learn and how to improve and how to get all the best of our technologies, engineers, but also the thinkers and those who influence the politics on a broader level. And I would say that I see more and more this understanding how much electrification could help in this context, because it's about efficiency, it's about which kind of technologies we have, but obviously this is still not enough. And I think this is why I'm very much looking forward for this discussion to see where we can get there. And thanks for having me.
Thank you. Poppy.
Yes, hello everyone. I'm Poppy Storm. I'm the Director of Innovation at 2050 Institute, and I came into this building decarbonization work via the energy efficiency industry, which in the Northwest is mainly focused on utilities. And so I worked in all aspects of utility, energy efficiency, but I really mainly worked in primary research. So doing large scale building stock assessments, also doing assessments on emerging technologies, worked on some of the seminal ductless heat pump metering and evaluation work in 2008 through 2013. And one of the things that really struck me in that work, and this is no offense to the utilities because they've done a lot over the years to meet load growth, but one of the things that really struck me when I saw the aggregate distributions within the building stock was that very little had actually been done over the past 30 to 40 years when you really looked at things in aggregate. And that was in stark contrast to what I could already see as the level of efficiency and decarbonization that's required to meet the moment in terms of our climate crisis. So I left my company that I had been with for more than 10 years in 2018 to start 2050 Institute, to focus really on using that 2050 lens and looking at everything through that back-casted lens. So I've worked on the 2021 Washington State Energy Strategy. I led the building sector research and policy analysis piece of that. I've also had the pleasure to work with Seattle City Light on their building electrification strategy, and I'm also just about to start working with the city of Tacoma on their decarbonization strategy. So really working at all levels, regional, state, municipal, utility, as well as mandates. I've worked on the development of the energy use intensity targets and greenhouse gas intensity targets for the building performance standard at the Washington state level, and then the GHG standard at the city of Seattle level. So I'm very interested in how a lot of these different levels of the larger ecosystem can work together to realize these goals quickly.
Thank you, Poppy. So we've got about 45 minutes for discussion. Cora, just quick time check. We're wrapping up by 11, correct? I guess
Yes,
11
correct.
Pacific time. I'm sure we're scattered across time zones. Wonderful. Okay, so first question, how important is electrification, or what's the role of electrification when thinking about decarbonizing the building stock?
I'll jump
Angela,
on
I saw you come off. Oh yeah, please, Colm, go ahead. Thank you.
Go for it. I think it's critically important. Without electrification, we're not going to decarbonize our buildings at all. It's really hard to do carbon capture on a building scale. It's hard to do it, period. But without a clean grid and all buildings electrified, we are very unlikely to hit any of our targets that we have for ourselves. I think Poppy probably has a lot of research in that front, but we as a utility that is mostly hydropower are really trying to set ourselves as the fuel providers for buildings, as well as in the future our transportation sector, so that we can support the entire decarbonization of our state.
Thanks, Coleman. Angela, I saw you come off of mute. Looks like you had some thoughts.
Yeah, I think it's important to note that, whenever you come up with statistics, they could always be proven wrong from things, but that the building stock is consuming 40% of our nation's energy. And so that obviously is a place to start. Like that's a huge impact right there. I mean, transportation is another huge impact, but if we can start by electrifying at the building level and eliminating the need for the fossil fuels at that level, then we can start strategizing at the utility level and our community levels to see what's the next step for making that reduction of fossil fuels.
Can I chime in on that, Emily? Yeah, I just wanted to agree with Colm and Angela, and we looked at this in depth in the state energy strategy, and as Carrie Mead mentioned earlier, the electrification in buildings really is the most strategic and lowest cost approach. And so it's really important right now when we have only 28 years to not go down dead end pathways. And it doesn't mean that there won't be individual buildings or individual instances where some other strategies might make sense, and the electrification certainly needs to be within a larger context of other strategies and approaches to make it the most effective, especially when looking at reducing peak loads when you're adding in that much electrification. But when you compare electrification in buildings versus maintaining most of the gas combustion equipment for space and water heating, you're looking at a difference of $34 billion cumulative over the next 28 years by 2050. So that's just for Washington State. So it's a really significant difference in cost when you crunch the numbers and add it up at a societal level.
Thank you, Poppy.
I would agree on this. So speaking from a very German perspective, the big challenge that we have at the moment is the challenge that our grids are kind of stressed because of the electrification that we see at the moment. We have at the moment, as I have shown, around 42% of renewables in the system, but definitely this is not enough. We want to go to 100% very soon. And that means that the grid infrastructure needs to change as well. And I think having storage system here is a big kind of help in two ways. Because first of all, you can use your electricity whenever you need it, and secondly, you can de-stress the grid. And thirdly, I think for the housing sector, because it's such an easy solution in a way, because all the technologies are already available. There are funding schemes that help you to decarbonize and to electrify in Germany. You can also help in terms of the industry, because then the industry can use the electricity from the grid. And I think there are a lot of beneficials that we can have here.
Yeah, that's a great segue into the next question. So in addition to electrification, what other solutions need to be considered with the built environment?
I can start and then maybe someone else can jump in. The first thing I think is let's not let off the reducing our energy consumption pedal, right? Like let's really stay on that. I'm a big advocate of let's make less stuff to start with. So, you know, reducing, figure out ways to reuse, to recycle. I think we need to look at the water and the wastewater side of things. Those are all things that are consuming energy somewhere, and consuming in general, just reducing consumption. Whenever I think about like the difference between the US and when I've traveled to Germany, just the level of consumption in the US is a whole different level. And it really puts me in a humility when I go to other places and see just how much we do consume. And so starting with, you know, the consumption level. And then the other thing I would really start, you know, we've talked a lot and over the years, I've heard a lot about this cradle to grave analysis, but I don't think we really look at that critically enough. And I'm really interested in seeing, you know, how just because we're designing and manufacturing products responsibly, thinking about how our future generations are going to dispose of those so that they're not left with what we're creating now.
I wanted to add a little bit to the emphasis on energy efficiency. I really agree, and I'd like to expand that beyond kind of normal conceptions of it in terms of envelope and also just technologies in general and extend it to good design. I think that that's just one of the most critical things for us to look at is how do we ensure that we have the best designs, that we are templatizing and standardizing and amplifying the best approaches and not considering the entire building stock to be, you know, by 2050, we'll have 4 million residential units and, you know, billions and billions of square feet of commercial space. And each of those buildings is not an individual snowflake. There are a lot of similarities, and we need to really be taking the 80-20 rule and making sure that we're getting the most leverage as soon as possible with the best designs for the widest swath of that overall building population. And we have started to do that in Washington State. We have a lot of design strategies that we're embedding within the energy code, which we're getting a lot of press for the electric and heat pump requirements, but I would really emphasize the role that design has played, and we've been very successful in integrating that into our energy code. Things like dedicated outside air systems, combined with heat recovery, combined with limiting simultaneous space heating and cooling in spaces. These are strategies that can save 30, 50% of the energy use in buildings. And we really can't move forward over the next 28 years without really capturing all of that savings.
I want to add to that. Well, first of all, yes, energy efficiency first. The smaller the load is that you need to serve, the easier it is to serve. And I think there are many additional benefits with electrification that are not just carbon reduction, but also I think we are already heavily moving into a different climate. We are seeing our summers change, our winters change. We have a significant shift in how we spend money as well. Energy is becoming more expensive, and therefore energy efficiency is going to help reduce bills, especially for energy users that are financially limited. So, and then I think in addition to that, we have to talk about resiliency, both for people. So can we get through the worst climate effects, and how quickly can we bounce back from disruptions? Because disruptions are going to happen. We are seeing much bigger storms happen all over the planet. Here in Seattle, we are waiting for an earthquake to happen at some point. We need to have our building stock set up to be able to deal with those disruptions and allow people to go back to normal life. We all know what a major disruption we've seen with COVID, and now, you know, Pakistan is underwater, the Colorado River is dry, Puerto Rico just got hit by a massive storm, same with Japan, like up to a meter of rain in certain locations, like ridiculous things that we've never had to contemplate before, we now are seeing every year happen. And by creating smart systems, smarter buildings that talk to the grid, that can operate in ways, if we have distributed energy resources that allow for communities to power themselves, to or to have critical resources come back up much faster after disruptions, those can only happen, I think, in a sustainable way when we do electrify and have a system that is properly integrated.
Maybe I can add to this. Thank you. This was a very interesting comment, Colm. Well, in Europe, we have something called the Energy Union. We try to develop an energy union or market through Europe. So every member state in the European Union is responsible for its own energy sources, but the market should be a common market. And something that is under this rooftop, something that was developed is called energy communities. And those communities at a certain level of a regional level, they can share their energy without kind of additional costs, so without grid costs and so on. I think this is a very big move towards responsibility, also to feel that you kind of have the responsibility for your energy on the one side, so you get much more availability, but also awareness of what it means. So you don't plug your socket into, plug something in your socket and you are sure that you've got your electricity. I think this kind of normal confidence will change within the next years. I like this a lot because on the other hand, we have all the devices and we have the technology to make it very easy. And I think today those examples show that there are all these technologies out there that help us, that we don't need to care about how to distribute it or how to arrange those technology, because it is all there. But it's a different kind of participating in this kind of energy market and to really get your own electricity out of this. And I really like this a lot. On the energy efficiency side, I would completely agree. However, I'm a bit skeptical because we see those so-called rebound effects, meaning that the more efficient you get, the more tools you get to be efficient, the more tools you get, and the more energy you, in the end, you will use. And I think this still is a quite big challenge as well. So that therefore all this kind of psychological factors will also factor in. And I think this is something to be discussed in the future as well. And my last point on the electrification is obviously efficiency in terms of how can we make best use of the energy, of the available energy. I can give you just one example. In Europe, we have quite a big wave of hydrogen, and a lot of people now believe that they can use hydrogen to kind of heat or cool their houses. I'm a bit skeptical about this because if you then compare hydrogen to other technologies, then you definitely get into this efficiency questions and the availability of hydrogen at the moment, which is something very different. So I think here heating and cooling will be most efficiently kind of provided with heating, with electricity. And my very last point is obviously the social factor. We have a lot of poor people now, and because of the high energy bills we get, the costs are really, really decisive for who you are in society and how you can participate.
Great, thank you. So let's talk a little bit about technologies. So what nascent or emerging technologies can support this transition to electrification and decarbonization? I can call on people if we need to.
Yeah, well, it's simple because I mean, you heard my contribution. I think energy storage is definitely one part of the solution. It's not the solution, but it's one very big tool to this. And I hope that we will get and we will see much more on this. And with some more regulations in Germany and in Europe, I hope that also the technology development will enhance now, and that we can see much more about this. But you heard about it beforehand.
I think the technologies that we're using in the US, we could be borrowing on what Germans might not even consider that technologically advanced. I kind of made a list of ones that I've been seeing emerging in the marketplace. I mean, not a lot of them are widespread and commonly accepted yet, but definitely heat pumps that can handle much lower temperatures will be a key. Induction heating, cooking appliances are something that we're starting to see more and more about. I mean, on using them for multiple applications, rather than just traditional stovetop. And then I had written down like the electric fireplaces that look really realistic so people can replace their traditional ones with that and feel more comfortable and feel like they're still getting that ambiance, but still are getting the heat from it and have it look real. When I kind of look at the technology sector, we think about sensors, controls, advanced energy modeling, and energy use measuring, all of that, and tracking the energy use. I think that's really something that we talk about a lot. And I'm looking forward to when we actually start using all that technology to make good decisions on making us have better performing buildings. I see us implement a lot of the technology, but I'm not actually seeing us take that and go back to the building stock itself and make changes.
I would just add on the technology front, simpler solutions that are for heat pumps that are more packaged and easier to install, especially for renters and things that can kind of be carried from one house to the next. So just making it, we think about that in terms of transportation and things being multimodal and kind of creating a whole system of how those different strategies work together. And I think we really need to be thinking about that in terms of buildings as well, that things aren't necessarily going to be stationary.
I think that we don't actually have any technological barriers at this point. All the technology exists. I think the main barriers, especially here in the US, is cost first and foremost, and then second, a close second is that the workforce isn't familiar with many of these technologies that we need to decarbonize our buildings. So when you visit a typical US home, you will usually have a ducted air system with a furnace associated with it, and maybe there'll be an air conditioning system too. Depending on where in the US you are, Washington State has the fewest air conditioning units per capita of any of the states. So, well, actually, Alaska may be lower, but we're very low on heat pumps here, and our technicians don't really know how to install them properly, don't feel comfortable. Therefore, it is more expensive. Coming from Europe with a very similar climate to Washington State, at least on the western side, I really miss not having things blow on me to keep me comfortable. Radiant heat is incredibly comfortable. It is actually pretty efficient as well, because you can decouple ventilation from your heating and cooling. And if there's anything I learned with in the built environment, you can have an HVAC system that can do heating, cooling, and ventilation, but it'll do a maximum of 2 of those things properly. The other part, it'll really suck. So having systems that are dedicated, that are electrified, should not be hard. And if we are smart, we tighten up our envelopes, make sure that our buildings are efficient so that we have lower loads, we can steal from other industries as well. If we have like passive house buildings, you can heat and cool those with an HVAC unit that is equivalent to a car unit. You can't buy those commercially, but they're available. They're out there. That technology exists. It's just, can we get our people comfortable with the technology? Can we bring the price down? And can we produce enough of them to get them in, like, proliferate them in our region?
Right. Any last thoughts on that question, Poppy? I saw you come off of mute, but we can certainly move on to the next one. Angela?
Yeah, I just wanted to build on one thing that Colm said is when I was in Germany, they had a machine that you could put your after you took it out of the wash, put it in the dryer. It just spun the water out of it. We don't have anything like that, where it just almost spun it to the point where it was dry enough on its own without adding all this heat to it. We don't have anything like that. So it's like you can't even buy those kind of products at our stores if you even wanted to try doing that. So I think that's really interesting, just like a basic level home accessory that we can't even like fathom buying.
Great, thanks for that addition, Angela. So I want to talk a little bit more about the role of humans. You know, people spend 90% of their time indoors between our homes, our places of work, where we go to school, where we spend time. So let's talk a little bit more about the role of human behavior. What needs to happen there, or how are we impacting our built environment?
Jumping on what Angela just said, I had the good fortune of actually being able to go and visit my family in Belgium and Ireland a couple of weeks ago, and all of the places that we stayed didn't even have dryers. So hanging up your clothes to dry was like standard practice. Is that something that we can adopt? Is that something that we can make bring into the mindset of people as being normal? Okay, how do we make those changes where we choose more efficient things just by making a change in our mindset? We like the most efficient thing is not to use energy in the first place. And this goes into many different things that I think are really challenging in the US. For example, our cities are built for cars. They're not built for humans. Our homes are much bigger and are much more reliant on energy use because energy is super cheap here. So when we think of how to live, we think of how to live in the environment that we are in, and we can make changes for ourselves, but we need to change what is considered normal, I think, and that is not an easy thing to do. And I don't necessarily know who would be the influencer unless we get everybody on TikTok to like dry their clothes online. There's stuff like that. So yeah. Interesting question though.
I think I agree with you on that. And I think some of we're not even in our society like talk about, showering every day is such a normal thing in US culture that even like our top movie stars can talk about it and they just get humiliated in the public. Like, how dare they not shower every day or wash every clothing, even if it's not dirty? Like just these basic cultural things where we just clean and wash and dry and clean and wash and dry everything to the point where it's a little like excessive. And when you go to other countries, like it wears your clothes out too, right? So like washing your clothes when they don't need to be washed wears them out, then you're replacing them more often. I mean, there's basic cultural differences that I think if we started kind of thinking about the way we do things. I think we're lucky in Seattle though. I mean, we have composted all our curbs. You go to other places in the US and that's unheard of. So I think that there's things that we can take from our culture in Seattle to other places in the US and start, there's ways that could be more normal, that we accept a lot of that's kind of changed over time too. So it's not all Debbie Downerism in our area, but it seems like we have a long way to go.
Yeah, I think in many ways, though, considering the pace and scale of this transition, that we have to make it as human-proof as possible. I don't know. Maybe I'm just agreeing with Colm here, but we need to make it so that the systems themselves are operating and they're designed efficiently, and that we're looking at things like multifamily versus single family, where you're inherently using a lot less energy just because of the size and the construction. So I think that it's, I mean, I don't know what the numbers are, and it's not to downplay how much all of that washing of mini loads adds up, but really it's space and water heating and lighting, which is basically just devouring enormous amounts of energy. And so once we, have that transition already going on lighting, we're seeing really dramatic differences actually finally after dozens and dozens of years on the building stock assessment. So the lighting is actually starting to make an impact. And if we have a large scale transition to heat pumps for space and water heating, that's just going to dramatically reduce the energy use plus design. So you get a lot of those really critical, essential elements of the energy use under control. I think that we're just going to have to tolerate a little bit of some bad decisions. It's not to say that we shouldn't be focusing on that at some level. It's just that in aggregate, I don't know how big of an impact it will actually have. It may, but I would just emphasize getting those bigger, more highly leveraged strategies in place at a really broad scale, large scale.
Maybe something that is new in Europe is obviously the need to cool. So cooling is a big factor, and you can see that it's really popping up north and getting more north. So I'm now Berlin based. We've got centigrades, like 10 centigrades outside there, so degrees Celsius. Now the heating period starts in Germany, but in the summer, I just moved into a new apartment and I had air conditioning. This was something that you couldn't think of like 5 years ago. I never used it yet, but you never know. So there is another challenge here as well. So you need a lot of electricity to cool. And this is obviously a health factor as well. So people get ill or sick because specifically in the south of Europe, they can't afford to cool down their houses in summertime. And this is why I think we need both. We need a very advanced policy that helps us to regulate and to help people to decarbonize their buildings and to electrify. This is something that is definitely needed. And unfortunately, and this is, I would wish to have different knowledge, but what we can see now, specifically in Europe and Germany, because of the crisis, people wake up. And this is something that I think is very sad from the psychological point of view. So only if you are really in the deep crisis, only if you see something really coming and very urgently coming, you will start to act. And I think this is too late. This is why, obviously, I don't need to kind of discuss this in this round, but I think this is something which is very difficult. So a single human can't move the world and can't change the world. We need to do this together, but we need both. We need people with a lot of awareness to act also as an example for others. And then we need good politics to help us to get there.
I think we just need to make everything as simple as possible. If you want humans to change, you can't be difficult.
Yes, keep it simple. All right, so the next question, what are some key policies that should be considered or prioritized?
Well, keeping in line with the keeping it simple mantra, I really think that a huge majority of the shift should be driven by the energy code and building performance standards, and also appliance standards and potentially limits on fossil fuel emitting appliances. So those three levers are really critical and could potentially address a huge majority of the shift. And we're already seeing that with our energy code on the residential side. We've seen, as we've increased the stringency, the heat pumps have entered into the most cost-effective path because there are so many total requirements for efficiency, and there's so much efficiency you get from the heat pumps. And so we have a recent study that shows that it's like 80 to 90% heat pumps in single-family residential in terms of the percentage of permits. So that is just an absolutely massive shift that's being driven by these types of policies. And then we really need market transformation, market development, kind of wraparound policies to really help the market actually transition in alignment with those policies. So I don't really think it's a lot of the central policies. We don't need that many of them for buildings. We just need to ensure that every segment of the building sector has a trajectory to 2050 to reduce their emissions to zero and to significantly reduce energy. And that can be built up by mostly with these central policies.
I think those are all critical. Completely agree with Poppy. And taking off my utility representative hat for a second, this is just my own personal opinion. I think carbon cap and trade is pretty much the only way forward, where we set a maximum target for carbon that is allowed to be emitted, and you can purchase your carbon allowance from other people who have reduced their are producing less than their carbon allowance. I think that is, especially for industry, large buildings, transportation, commercial transportation, those are the things that need to move fast, and they need to have a financial driver. I think without a financial driver, we're not going to get there. Even if we set building performance standards, those are really key to driving building emissions down, but there are so many other emissions that we need to be taking into account, and industrial emissions are going to be a really tough nut to crack if we don't have a very clear financial indicator for them to use for how to move forward.
I wanted to kind of build on what you two said a little bit. Like I've been involved, like Poppy has, in the development of some of the Washington State energy codes. And I think it's interesting that if there's a way around it, people are going to find the way around it, and really making sure that, you know, the right people are at the table when we're writing those so that they make sense. I think some of the codes that we had to follow really didn't technically make sense at all to the actual people. This is what I do for a living, and I'm reading this requirement. I have no idea what I would even do here, how that's even possible. And that would be every project throughout Washington State. So making sure that those codes make sense, and then making sure that they're, you know, it comes down to are they actually being implemented, and are they actually, you know, are we actually enforcing it? That's another thing I see is, you know, we need to educate the people who are enforcing it so they understand, one, the reason why it's in there, and then what they're looking at, because I think a lot of times the people who are enforcing it don't understand the technical side, and they're just signing off because they don't quite understand the nuances of all the technical reasons behind it.
I think probably one other thing to consider if we're talking about policy is how the more vulnerable, poor members of our society cannot be left behind. This transition is going to cost us a lot, but it's going to cost us much, much less than if we don't do it. So if you were to look at the predicted cost of climate change from companies like Munich Re, the insurance company, then we are talking trillions and trillions of dollars if we don't make the changes, and it is much, much cheaper to make those changes. Now we just need to figure out who is going to benefit for it from these changes, like those insurance companies. How much can they save, and how do we get that capital available to make those changes? And that is, I think, somewhere between the financial institutions and government. We need to really figure out what is it worth for us to do it versus not do it, and get everybody to come along. And those are hard conversations to have, and there's political divides on big government telling us what to do versus in America, bootstraps, you do it yourself. That's not going to be an opportunity. I think we can't do it that way. We have to have a concerted effort with the finances being made available. I think we're going in the right direction, but we're not there yet.
Right, so Colm, I'll lob the next question to you, and you can decide whether or not you want to wear your utility hat while you answer it. But what role are or will utilities play in this transition?
We have to be the cornerstone for a resilient society. We have to have a grid that is decarbonized. We need to have a grid that can recover very, very quickly from any big interruptions that it might see, be it weather-based or otherwise. One thing that comes to mind, for example, is utilities are under constant attack from hackers at this point in time. So it is more than just weather that is going to affect us. Weather affects the world political stage and drives up tension, and that is something that utilities need to be in a place to deal with. We can support a lot of the change. The programs that we manage, financing, rebates, supporting technology, early adopters, market transition, those are all things that the utility has a role in, but we can't do everything. I think there is a lot to be done at a regional level, at an international level, with a lot of collaboration, and having your utility at the table is going to be really important so that we understand the change that you want to make and that we can support that. So talk to your utility. If you ever have any utility person on, they will say, talk to your utility. They want to know what change you're making and how they can support you. We are scrambling. We are trying to move from an industry that has been operating the same way for 100 years. And we were happy stuck in the 1980s, essentially. When I joined the utility 6 years ago, it felt like I was joining the 1980s again. And now we are trying to jump into the 21st century and leapfrog a lot of the changes that should have happened that never happened. We were focused on getting people the right bill, and that's it. Now we are trying to understand how we can be field providers, how we can be resiliency centers, how we can deal with climate change, how we can help people meet their climate goals. So there's a lot for us to do. It's never going to be boring.
I would just to step in, I encourage us to look at what the utilities have already done that have been successful. And I think at least in Seattle area, the LED, I think utilities were a huge part of one, educating the public about LEDs, giving incentives, getting them out there. I mean, public likes free things, and they were making LEDs freely available, and to the point where they're just a lot more commonly accepted just because of that huge. And I feel like utilities were a huge part of making that a commonly accepted thing. So I think in continuing to encourage kind of that education aspect, I think the utilities tend to have an audience. They send out pamphlets. They have facilities that are dealing with, both the power and the water and the wastewater side of things, and using that as educational opportunities. I think, that is a platform. And I think that that's one of the ways that even I think about my children in the elementary schools are being educated by the utilities on waste and water and electricity and garbage and all that. And so I think continuing to do that, I think, is important.
I think that above and beyond just utility programs, I think that there will be an increasing role for utilities in terms of market transformation. So we have had a lot of great market transformation efforts around energy efficiency in the Northwest, but my sense has been that there's never really been a true endpoint or a sense of a timeline. How much are we trying to transform and on what timeline? And now that's what's really different about decarbonization, is that we have this capital D decarbonization, which is essentially total decarbonization on a finite timeline. And when you crunch the numbers, you really see that we need a market transition very early in the process. So we're looking at, based on the state energy strategy numbers, needing to switch over to having all new and replacement space and water heating be high efficiency electric by around 2030, between 2030 and 2035. So that's a very clear signal around the market transition that many of these policy and programmatic efforts really should be focusing on as the central target of their work, because that's a huge transition. So we're looking at transforming the building stock by 2050, but we really need to transition the market within the next 10 years. So I think that utilities should be looking at how they can play a role in that transition, not just through their programs, but also as clients to the regional organizations and kind of pushing a regional approach to market transformation, because they're the ones who really have to deliver on the transition in terms of the load.
Copy. Constance, any final thoughts with that last question? All right, well, I want to say thank you so much. Oh, go ahead.
I couldn't agree more on this. Thank you.
I want to thank the panel members for the discussion. Really appreciate it. And our time has come to a close.
Thank you, Emily. And thank you very much, Constance, Angela, Poppy, for sharing your insights of how we can make buildings more sustainable. It's been a pleasure walking you through today's program, and I hope everyone was able to take away some key insights. We here at GACC West appreciate you all taking the time to be here today. And if anyone has any further questions, please do not hesitate to reach out. Our contact information can be found on our website, gaccwest.com. Thank you so much and stay safe.
Thank you. Bye.